Welcome to the Zimbabwean Private Schools Robotics Olympiad. I'm your host, Shungu. So in this particular presentation, we're going to walk through what robotics is, what the Zimbabwean Private Schools Robotics Olympiad is all about, what you can do to start a club at your school, the kits that you need, the costs, the important dates, and the reward impact of robotics. So let's go straight into our presentation. So welcome to the Zimbabwean Private Schools Robotics Olympiad, which is going to be a platform where we are going to be meeting and competing in the world of coding, electronics, and robotics. Our events are going to launch off this September of 2025, and our tagline is empowering learners through robotics, creativity, and reward impact. So basically what you'll be doing is you're going to be given tasks to go and solve a reward problem using electronics, coding, and robotics. And we're going to meet and do competitions, and we're going to be selecting our winners. We're going to be having our panelists, our judges, looking at each and every project and judging the projects, awarding prizes to the winners, and so forth. And we're going to be learning a lot together as a team. Why this function? So Zimbabwe needs homegrown innovators that are equipped for the 21st century. You can see that the technologies are always improving. We have new technologies each and every time, and we need to catch up because technologies are continuing to change, grow, and expand. And this program, the Zimbabwean Private Schools Robotics Olympiad, is going to align with Education 5.0, which involves teaching, research, innovation, industrialization, and community service. We need to know that robotics is an important gateway to critical thinking, STEM careers, and also national development. We're going to talk about the power of the Arduino. All the robots that I'll be showing in this presentation, all the robotics kits are going to be Arduino based. So what is this thing called the Arduino? It is the brain of the robot. The brain of a robot. It's a microcontroller or a small computer that can be used to control actuators such as motors, servo motors, LED lights, your buzzers, your speakers, and it is also capable of supporting sensors. So you can connect sensors to the Arduino. You can connect actuators which are controlled by the Arduino. And this setup allows you to build robots. So this is a versatile tool in our journey of robotics and electronics. You can get kits from as little as $30 and under to launch your robotics journey, your robotics club at your school. This Arduino is flexible. It supports sensors, motors, wireless modules, and many more things. It is scalable from basic coding to some industrial automation, which is very, very important. It is also accessible, ideal for rural and urban setups. The Arduino kits are available in Harare. You can order them directly from China, and I'll be showing you some of the kits that you can order to start your robotics journey. So let's look at some of the kits that you can also order. So there's your board that you can order for your coding, electronics, and robotics. So let's look at what is inside that kit. So it comes with the software that you use for your coding. Okay. So several modules that you can also connect to this kit. Several robots that program it and use it for a specific task. Okay. So the Zimbabwean Private Schools Robotics Olympiad is going to have some competition categories. These are just example categories. We're going to place people in their correct categories. For example, grades 5 to 7, which can be given their specific challenge, such as to design and code a smoke and fire detector with an LED and alarm warning system. We can have our forms 1 to 3 being challenged differently. For example, to design an irrigation system that automatically turns on and off depending on soil moisture level. We can have our form 4s and upper 6 being tasked to solve a real world problem of their choice, such as creating an automated wheelchair. This would be assistive technology for the disabled. Prototype industrial conveyor belts, color sorting machines, line followers, energy saving devices, and IoT devices. So they're going to be competition categories, and they're going to be judges for each category. Okay, let's talk about the real world impact of Arduino and robotics. So it's not just a game, it's not just toys. There's a real world impact here, which involves agriculture. In agriculture, we can build smart irrigation systems that involve soil sensors, pest detection sensors, and we can collect data from our Arduino based devices and link that information with professional software such as AquaCrop and be able to predict our yield and do climate smart farming. We can do geography and climate. We can have our Arduino powered weather stations. We can collect data for research and forecasting using our Arduino devices that we would have built in our coding and robotics clubs. We can do environmental management. We can use our pollution sensors for air and water quality, and we can integrate the data that comes from these Arduino based devices with professional software such as the AquaTalks, which is used to monitor aquatic ecosystems. It's also used to study the effect of pollutants in aquatic ecosystems. So this is an example of a professional software, the AquaCrop, that can be used together with the data that's coming from your Arduino based device. This is the AquaTalks. So we can have real world impact with Arduino and robotics, coding, and electronics. So it's important that you learn this. It's important that you join us, form a club at your school, and start to train your teachers, start to train your students so that they start early to understand these systems. We can go into safety, health, and assistive technologies. We can design fire alarms, gas leak detectors using our Arduino. We can create assistive technologies for the disabled, for example, smart glasses, distance measuring devices, object detectors, automated wheelchairs that are joystick or smartphone controlled. We can do Arduino based health monitors, which monitor and measure our heart rate, temperature. So this is some important stuff that we can do using our Arduino. We can simulate safety PLCs or programmable logic controllers using our Arduino, using our simple relay switches. We can move on to understand the Arduino Opta, which is used in industrial automation. So we need to start somewhere. Okay. We can talk about energy saving and industrial automation, which I just talked about. Smart energy meters can be created for homes and schools, Arduino controlled industrial systems. We can also use the Arduino to modernize old car engines. So there is a real world impact for Arduino and robotics. We can talk about rescue, disaster, and drone technologies. We can create search and rescue robots for collapsed buildings, Arduino drones for mapping, delivery, and surveillance, early warning systems for floods, fires, and landslides. So for people to be able to do all this, we need to do capacity building. So we're going to have student and teacher workshops at Excel Glendale Academy, where we're going to be teaching people about the Arduino, about sensors, about coding, and our mentorship model is such that we should have at least one teacher plus 3 to 5 students per team, and we're going to be emphasizing. So we're going to require documentation for the projects. So we're going to emphasize on professionalism and building communication. So come and join us in this exciting journey of coding, electronics, and robotics. So there are going to be awards for the gold prize, the silver prize, the bronze, and special awards which involve best female team, best rural school, best innovation pitch. Okay, so we're also going to partner with the Ministry of Primary and Secondary Education, universities, tech hubs to bring in professionals from the industry to come and help us in our projects, in our competitions, as judges, as facilitators. So let's see some more robotics kits and things to expect in your journey of robotics, coding, and electronics.
Hi, I'm Joseph Schlesinger.
And I'm Connie Few.
And this is Sparky. Sparky is a simple-to-use, open-source, Arduino-based robot. The lowest-cost full-feature robot on the market. And is an engaging introduction to programming, electronics, and robotics.
Sparky is very easy to use and to get started with. Just take it out of the box, plug it in, download our customized Arduino software, and get started with any of our dozens of programming samples. Or you can write your own code in minutes using our online tutorials. We've been conducting pilot classes with elementary and middle school students and have been amazed at what they can do. We are working hard on enhancing and expanding our curriculum for Sparky, improving the lessons and code used in the class. Sparky is easy to use for the beginner.
Yet feature-packed enough for even the most passionate enthusiast or researcher, and is aimed at anyone looking to learn these subjects or to have a comprehensive robotics platform for their own projects and experiments. Sparky includes a servo-mounted ultrasonic distance sensing head, 3 light level sensors,
a 3-axis accelerometer to detect the current angle of the robot,